Okay, so here's our first example, and the only example we're really going to look at in terms of solving the triangle. We're going to do one example, and then they're all pretty much the same, as long as they have, like I said before, two angles and a side. Now for this triangle right here, we have this angle, we have this angle, and we have this side right here, okay? So what we would say is that this is the included side between these two angles. Recall that from your geometry days. It's the included side because it's the side included in each of those angles. So for this scenario, we would say this is an angle-side angle relationship. If you want to find the rest of the information here, we can use the law of sines to do that. Now there's one thing we can do without using the law of sines, right? Okay, I can find this angle right down here. Because I know two of the angles, I can find the third angle by finding the difference between those and 180 degrees, so that would be 180 minus. If you add these together, you get 151.3, and the difference of those is 28.7 degrees. So this is 28.7 degrees down here. Okay, if we label the rest of what we don't know, we'll call this C, we'll call this A. Now with this information, what you need in order to use the law of sines, okay, what you need is an entire ratio. You can't have a missing piece from each one of these, okay? One of these three ratios needs to be complete with no variables. And that's the linchpin, that's the most important piece to solve using the law of sines. So that's why finding this angle was so important. Because now I know this angle and I know this side. Before I knew this angle but not this side, I knew this angle but not this side. So I had to find that third angle first so that I could set up this ratio between the variables B here, the angle and the side. Now I can use this to solve for whatever's missing. Okay, so in this case, let's say, it doesn't matter, at this point we're solving for either one of these sides. Let's find A, right? So I set up the sine of 49 degrees over A, and it doesn't matter if this is flipped over, if you have the side length on the top and the angle on the bottom, you know, like take this entire piece, move it down, take this entire piece, move it up, that's fine. This would just have to be in that same relationship, right? So I'm solving for this variable down here. When we solve proportions like this, I like to go slowly, I like to go step by step. I'm going to cross multiply, which is, I'm sure, the way that you were taught this. So this is A times the sine of 28.7 equals 27.4 times the sine of 49. I think I still got my Desmos warmed up here. If you're going to use your TI Inspire, that's fine, okay? But when you're doing this, make sure, make sure if you're in Desmos, click the wrench. Make sure you're in, click the wrench and make sure you're in degree mode, okay? I believe if you open it right away, it's going to be in radians. Just make sure you're in degrees here, okay? And if you're in degrees, we can type in 27.4 times the sine of 49. So we get 20.67904, blah, 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 blah. Okay, a lot of rounding involved here. I think I'll go to the thousandths place. 20 points, we're not NASA, right? We're not rocket scientists. We don't have to have that much precision. So 20.679 for this. There's no variables there. So we said 20.679 for that, and that's equal to A times the sine of 28.7. For as long as you possibly can, keep that ratio intact. Like this represents a number, right? So divide, you don't need to calculate that into a decimal right away. Divide by it on both sides like so to get your value of A. So if we take that, now again, the nice thing about Desmos is I can take this, copy it down here, okay, and then divide by the sine of, was it 28.7? Is that right? Let's see. 28.7. Okay, so even though I rounded it on my paper, I don't have to round it here on the calculator. I get 43.061. Okay, 43.061. So we're in the middle of this problem. I've really only found two pieces so far. I found A, I found side A, and I found angle B. But just check real quick, I got 43.061 for side A. So this is 43.061 now. All right? So far, do my numbers work, right? When I say that, this is the smallest angle. This is a side that is smaller than that, right? 49 falls in between these two values. So at the very least, the side across from this angle has to be greater than that side. Okay. Now after we get to this point, we're not done until we solve for everything. I still need to know what letter C is, what side C is. So I'm going to say the sine of 102.3 over C equals, and then I have 27.4, so the sine of 28.7 over 27.4. We're going to solve this the same way we just did, okay? I'm going to fast forward this on Desmos. 27.4 times the sine of 102.3. Does that look right? Yep. Divided by the sine of 28.7. So we get 55.74. 55.747. So we get 55.747 for C. My math is good there if I was using the right numbers. So up here we get 55.747, which is good because this is the largest side compared to these two, and it is across from the biggest angle compared to these two. Okay? So